Welcome to the new session. In today's session, we will be learning about how to draw the front view, which is in section, top view, and for the given figure, it will be the right hand side view. So for that, we need to plan the paper space. We need to decide what are the dimensions of the total figure, and then we will be finding out the space between which our sectional front view, top view, and the right hand side view for the given figure will lie. So let us start with the line. And now for the given questions, we will not be starting with the midline because we can see that if you're looking in the x direction, we will be able to get the sectional front view. While looking it from the top, we will be getting a top view, and while looking in the right side view, we will be getting a right hand side view. And for the paper space, we can easily get to know that the side view always lies on the left or right of the front view based on whichever the side view is asked. So in the given figure, we can draw the front, we can draw the sectional front view, top view, and the right hand side view. So the right hand side view should lie on the left of the front view. So let us take the ortho mode on. Then we take the bilayer 0.09 thickness for drawing the paper space. First, we will draw the vertical line. Let us draw the horizontal line, which will be intersecting this. Then we take an offset to take a distance between the xy and the x1. This is the xy line we draw. Then let us take this xy and y1 line in this way. Then let us find out what is the overall dimensions of the figure. As we know that in the sectional front view, we will be getting a length and the height of the figure. In the top view, we will be getting a width and the length of the figure. And in the right hand side, we will be getting a height and the width of the figure. So let us find out the length. We can see here, this is the leftmost part of the front view. So this is 15. Then this is 60, which is the distance between this center line and this edge of the rectangle. So that becomes a 75. After that, what we see, this 75 starts from the center of this circle and it ends at the another circle here. So we add this 70 with the other 70. So that becomes a 150. And then we add this 23. So the total length of the figure will be 173. So let us take the rectangle. Let us take this corner as this is the position where our sectional front view will lie. Okay. So we take the 173 tab and let us now find out what is the height. We can see that the height of the figure from the bottommost to the topmost part is 60. So we type here 60, enter. Now we know that for drawing a top view, we need to determine what is the length. As we already determined the length, we need to determine what is the width of the figure. We see that this is a rectangle 60 and the diameter of this outside, so we can say circle, is 60. Okay. One thing we should notice that even though the two concentric circles are mentioned here, the inside diameter of the circle will be 40 and the outside diameter of the circle will be 60, even though the radius seems to be not matching with the boundaries. Sorry, or the dimensions are not matching with the boundaries. So let us take the rectangle for the length, which is 173. Tab is the 60 is the width for the given figure, right? Now let us shift to this polar tracking and let us check whether the 45-degree angle is there. And then we draw a line that will help us in drawing the projections in this way. And we can see that this green color dotted line appears on the screen because of the F11 mode is on. Now, what is that F11? It's a polar tracking. You can see this is the polar tracking. Now if sorry, it's object snap tracking and the polar tracking mode is also on. Now why this is there? Because from the customization menu, we can see that object snap tracking here is check mark. That's why it is appearing on a screen. Now we know that the height of the front view and the height of the right hand side view here will be same, whereas width of the top view and the width of the right hand side view is also same. So let us take the rectangle for this paper space. Then we will determine the first, we will set the width here, which is 60, tab, and then here height will be 60. Once it is done, then we will proceed for drawing the top view first. Now why top view? We can start with any of the views, but it is preferred to start with the view in which involves the more number of circles, and the circles which appear in their true shape, that is in the top view, if you look it, we see that this is a circular hole, this is again a circular hole, there are two more circular parts, so it is easier to locate the other views in reference to this. So we take a center line keeping the line thickness at 0.09, and we determine the location of this circular part. So we see that this figure is symmetrical about this center line. So we take this mid portion of this and we draw it in this way. Okay, so this center line divides this top view into the two parts. Now let us determine what is the location of this center as well as for this. We can see that this is the rightmost part of this top view while looking in the top direction, and its radius of this circular part is 23. So we can take this from this edge, a distance of 23, and then we can mark it the center for this circular hole. Now what we can do, as we know that this center to this center distance is 75, so it is better to take an offset, and then setting offset distance as 75, and then we mark it. In this way we have find out what is the center for this circle. Now once you have found out this, we will take the line type as a bilayer 0.30 thickness, and we will draw the circular parts. So let us start with the smaller circle whose radius is 20, right? So in this case, we can say that there is one more correction we can do here. Radius, instead of the 20, we can take the radius as 10. Radius, we take it at 10. And for the semicircular part, the radius here is 23. So we take the 23 as a radius. And we see that it is not a complete circle, but it's a half circle or a semicircle. So we can trim off the edges in this way. Okay. Then we will proceed for drawing this circle, which for which we already taken the its center location. So in this case, we can see that what is the diameter here, 40. So let us take the radius as 20, and then what is the outside diameter here, 60. So the radius is 30. Okay, so as we already taken the boundaries, so we need not to what type the diameter, which is a 60 or the radius 30, right? Now we can see that this semicircle touches this cylinder, right? So what we can do from this, we can draw one line like this and like this. Now one thing you can notice here, that here ortho mode is not on, but the polar tracking mode is on, because of which without even intersection of this circle with this edge, we are able to draw the edges which are connected here. So if we have a ortho mode is on, then we might have to extend it, and then we might have to trim this part, right? So this is one advantage with this. Now we have drawn this circle, we have drawn this semicircle circle, and then we can see that this is a rectangular portion on the left that we can draw, right? So here its length is 60, and here we can see its width is 15. So here we type the 15, and then we can complete the rectangle. Now we see that this rectangle is connected to the circle by this portion of 10 mm, which is a rim. So let us take this a distance of 10 mm from the midpoint, and we will take the 5 mm here. Let us touch it, and then we can mirror it about the center line. In this way, we do not want it to erase the source, so it's complete the part. So now we can see that this rectangular portion is connected to this cylinder with the help of this rectangular portion. So to indicate from the top view, we need to draw this line which is touching the cylinder on this side as well on this side. But why we need to draw it on this side? Because as the figure is symmetric, if there is an edge which is connecting here on this edge, so there should be another edge also like this. So this we can see it. If this is the edge here, right, similar edge should be there on the other side also, right? So to indicate that, we can draw it. So we start it from this corner, right, and then we touch it in this way. Similarly on the other side also. Now what is the part which is left out for the outline? You can see this is a rib whose width is 25 and it starts from the edge of this, we can say, cylinder, right? So for that what we can do, we can just take an extension from it and then just take a 25, just take a 10 width, and then we can connect it in this way. So now what we have seen, we have drawn all the visible parts. Now we need to proceed for the hidden lines which might be there in the top view. Now we can say that for this top view, these are the two circles which won't be visible if you look it from the top end. Where what is the location of these two circles? The distance between these two circles from their center lines is 35. So what we will take? We'll take the line type as center line with the line thickness as a 0.05, right? We will take a line at a distance of 17.5 from the center line in this way, right? And let us slightly extend it so that it looks like a center line. Another way is, if even after the drawing a center line, if the line does not appears to be center line, what we can do, we can use the command called as LT scale. Mind it, but that even if you use the command, it will change the scale of all the lines such as hidden line as well as the center line or any other line types you are using. So instead of 1, we can set the 0.80. We can see there is a change in the distance between the small line gap and the larger line, right? So the lines will become more closer. So now we have already taken that. So now we take the offset so that we can offset this line by 35 or we can mirror it. So let us take here 35. So we can see that this is the centers lines for the two circles. Now we'll change the line type to the hidden, and then we can draw the boundaries for the two circles whose diameter here is 16. So let us take the line 8 on this side, right? So now we will mirror this line about this center line, right? Now we will select both together. We will mirror it about this center line. Okay, so that in this way we will be able to draw the hidden lines in the topic with minimum minimum we can say efforts, minimum time. Okay, so this completes our top view. So now let us proceed for the sectional front view. So for the sectional front view, we will be again shifting to the 0.0 line thickness and the bilayer, and then we can proceed for the different projection lines which are needed to be obtained from the top view. In this way we can extend these lines upwards later on. Just we will bring it to the front view first. You can choose to have extension till wherever it is required in the this view, like this. We can repeat the command by using the space bar, right? In this way we all projected all the required lines. Then again we will shift to the line type as keeping the bilayer with the thickness as 0.3. Now while looking in this direction, what we should notice that, right, if we cut this figure, then what we see, let us click the line here. This is the portion where we will be cutting this object along this line, right, and then along this line, and then along this line. Now once we cut this, we need to find out what is the remaining portion of the sectional front view. So for that, let us find out what is the remaining portion. We can see here we should get a portion like this. So these are some of the edges we should get. Then here this is the portion of the cylinder will be remaining, right? Here there will be the portion of the cylinder that is getting cut, right? And here this is the material which is getting cut, and we can see that once we take this cut here, this is the portion of the cylinder which is remaining uncut, right? So this will be remaining as a rectangle. Now if we proceed ahead, this is the rib which is getting cut longitudinally, so we will not be sectioning it. And then here we can see there will be a cut here at the edge of the boundaries of the circle. Here also we will be taking a cut, right? And then we will be connecting this by using this line at the boundaries in this way. Okay. So the portion of the cutting plane which is cutting the material, that we need to section it by using this hatch command. So let us start drawing. So once we understood where need to be taken the cut, where need to section, and which portion needs to be retained and which portion needs to be removed. So the line which represents a section, how do we indicate? See that this is the A to B portion which shows the section line, and by looking in this direction we can see that the portion of the this view while looking in the direction of X, between this line and the observer needs to be removed, and portion which is beyond this AB needs to be retained, and where there is a material that needs to be sectioned, whereas whenever the rib is cutting like this, so this is the portion of the rib which is between this rectangle and the cylinder, and this is the rib, this needs to be not to be sectioned. So let us start with from the top of the figure. So here we see that it's a 45 mm line. So again switch on the O snap. So this is 45 and the width here is 15. Okay, and we can say that who's from this corner to the bottom width is 45. So it's 45. Now where does it should end? We can see that once we cut that, it should end at the inner portion of this cylinder. So we will take that length till here. Okay, or we can take it till this edge of the cylinder. So let us take this edge, right? Now once we cut this, we can see that this inner portions of the cylinder will be completely visible. So let us take these portions in this way. So we can say that these are the two boundaries which will be visible for whole figure, and even after cutting, this top boundary of the figure will be visible. So we can extend it till this edge, and let us extend it till the outside edge, this edge. So from this corner, or we can say edge of the sectional front view till this edge of the cylinder, we have drawn a line by taking this line as a reference. Okay, we can see that in this way, right? Then what we can do, we can take this portion of the cylinder with how much it is. The height of this portion is 15 mm. So we can start from this corner. It is 15, and we can see where it is touching. It is touching to the cylinder in this way. Okay, and we can see that it is touching in this way, and then now it is connecting in this way, right? So now we see that this is the bottom of the figure, and that is needs to be continued till this cylinder's bottom edge. So we connect this till here, and then we join it in this way, right? Now what needs to be drawn? We will see that there is a one more line that needs to be drawn in this way, which is showing the thickness of this rectangle. So what is the width here? 15. So this is also 15. So let us offset this 15 mm this way and this way, right? And let us trim the portion in between in this way, right? And let us extend this, and let us trim the portion here. Sorry. So this completes most of the portion of the sectional front view. Now what is left out? Once we cut this portion, we see that these are the two edges of the cylinder will be visible. So let us draw these two edges, right? Let us extend the center line. We can draw another center line also without extension. So we'll take a reference of this and let us continue it from here in this way. Similarly, for this side, in this way. Now, one thing needs to be noticed here that after cutting this figure from the AB, this hole which is behind this section plane, that is, it is not getting cut. So how to show it, right? And what is its position from this edge? Its position is at a distance of 15 mm. So for such cases, if there is a circular hole which needed to be shown it by hidden line, we generally omit it. So what we can do, we can just show a center line for it. What is the location? Here it is 15 mm, and in this way we can show it in this. And then we will proceed for drawing the section. So before we proceed for the section, one rib is remaining. So we'll complete that rib. So what is the location of the rib? Rib starts at this location at 25 mm and it touches the top of this figure in this way. So now for the section, we prefer to have the line thickness to be 0.09 and bilayer. And let us take this hatch. Then we need to select the ANSI 31 as a pattern of hatching. We select this in this way. And one thing you should notice that what is the default setting here? Pick the internal point, which is better in this case. In this way, it shows the complete figure. And one thing you can notice that this is the portion we are not hatching because this is a relatively thin portion which is connecting the two different larger parts. So we are not sectioning that. Now let us draw the side view. For the side view, what we can notice that while drawing the right hand side view, first we think that let us remove this, the lines we have drawn. Okay. These are the reference lines we have took. So we will delete those. Okay. So I will delete first and then I will, okay, delete. Oh, sorry. So it is giving troubles in selection. Okay, let us keep the other lines as it is. Okay. Now, while drawing the right hand side view, what is the first thing that we see? This is the portion that we see first. Then this is the rib that we see, which needed to be drawn as rectangle, and then we see this uh, cylinder which will be observed as a rectangle. And one thing we should observe, one more thing here is that it's a figure is symmetric, right? So we'll draw a center line first to indicate the symmetricity in this way. Okay. Now let us select the location of the centers for the circles which are appearing as a circle, but because of this large cylinder, we can see that these are the two circles won't be visible. So we won't be drawing these circles at first. We will be drawing the visible parts first. Okay, so the line thickness is 0.3. So if we start it from the left or the top or the right edge of the figure, we see that the cylinder occupies the whole left, right, top and bottom of the figure. So we complete with the help of rectangle in this way, right? Because height of the rectangle is 60, its width is also 60, and this is what is the length and width and the height of the figure. So in this way we completed the outline of the whole figure. Then we need to take some of the projections from the top view. So we select this. These are some of the critical elements that we need to select in this way. Now you can notice here that with the help of this polar tracking on, without even drawing the projections, we will be able to select the edges, which sometimes it becomes difficult whenever the ortho mode is on, but you can choose the ortho mode. So these are the projections we have drawn, and then we can see that what is the height of this part is 15, and it will be observed as a rectangle in the side view. So we take a rectangle again, right? So its width is, here is 46, which is nothing but the distance between the two lines. So we type here 46, tab. What is the height of this? We can say that the height will be equals to this much, right? In this way. So now it should have been thick. So we select the match properties in this way, right? We can see that we have drawn this rectangle for this part. Now we have to draw this rib, which is starting just above the rectangle and it touches the top of the cylinder. So how we can draw? We see that this ribs is symmetric about this, so we can extend this rib from the projection lines in this way, right? Similarly, in this way we can project it, right? And then we can trim it the portion here which is of the rib which is not required, right? And then we can select this match properties in this way, right? Now this much is drawn, so visible portion is almost drawn. So what is left out now is the hidden lines. So first we'll draw the hidden line for this cylindrical hole. So let us select the hidden line. So we can project this hidden line from the top view. You can see that. Okay. We start from here and it ends here. Now we can trim in the portion of this hidden line and delete this. Okay. Because we do not want the projection to be hidden line. So what we can do now, we select this, we mirror it about the center line, and we don't want the source to be erased because we need it to replicate. So in this way we have drawn the hidden line here. Similarly, we need to draw the hidden line for this circle which won't be visible. So let us also project it. What is the thickness? Yes, is 15. So it will be visible only in this part. So now let us trim the portion, right? Let us delete this and now select this, mirror it about the center line in this way and not to erase the source. So in this way we have drawn the hidden lines for this circular part and hidden line for this circular part. Now let us draw the hidden line for this circular with the help of hidden lines, right? So now for that we need to extend this center line first. In this way we extend the center line from here. Now what we can notice that the center line doesn't appear to be a center line, so we will use the LT scale to further reduce the scale of the lines. So let us take it to point 60 and let us check if it is visible. Yes, it is now visible. So in this case, we'll minimize this line and we will extend this line further here in this way. Okay. Now we select the circle. What is the diameter here? 16. So radius should be uh, 8. But we need to know the location. So how we can know the location? See this. For that, we can transfer the locations from the top view. For that, we need to zoom it. So we can see this if it is yes, it is already corrected. So here is the center line for those circles. We are trimming it the part of the center line which is not required, and then let us mirror it about this mirror line in this way. Okay. Now let us take the shifting to the hidden line again. Circle as a command, and this is the center, and let us take the 8 mm as the radius, right? Then we can mirror it again in this way. So this completes our circular part for the circles which are hidden while looking in the right side view. Okay, right? So if you are zooming in, so you can use this zoom extends so that our whole screen will be visible. Now there are two hidden lines which are remaining. If you're looking in this direction, that is looking in the direction where the observer is, we need to look it in this direction. So while looking in this direction, what we should notice that these hidden lines which are connecting to this rib are won't be visible. So let us draw those, selecting the bilayer with the hidden line. So it starts here and touches the this rib. Similarly, this is on the other side also because the figure is symmetrical. So mirror it and keeping the source as same. Similarly, we can see that there is a small portion of this, we can say, cylinder which won't be visible, right? So that also needed to be drawn, right? So where does that? This is the portion of the cylinder which is behind. So from this edge to this, and from this edge to the left edge, it will be needed to be drawn as hidden. So here it's very small part, right? If the line scale of the is not small, it won't be visible in your drawing. So now we have drawn all the parts which are visible and the hidden. So this completes the we can say figure. So now the next part is we need to draw the important dimensions. For that we check the bilayer 0.09 thickness, and we can use this annotation toolbar. Before we proceed to the annotations, we need to select what are the different settings we need to make it, right? So we go to this dimension style manager, we go to the modify, then we can select the text size as 3 or 4 as per the needed height of the figure. We go to the ISO standard here, then we might go to the primary units, we go to the period, and we can select the precision at 0.0, right? Because here some of the figures having the decimal requirement, or you can keep the 0 if it is not required. Okay, so let us keep the 0 now. Okay, then you can make the offset from the origins if need here. Okay, and keeping the offset from the origin as 1, you can see this gap, and this is the dimension extension beyond the dimension lines. I keep it okay. Set current is important, and then close. Let us click the diameters first. You can see it's 40. There it is, 60. Okay, then this is 20. Then here we take the radius. Then let us take the thickness of this. Okay, one thing you must have noticed here, that because of the O snap in between on, it might face the dimension closer to the snapping points, right? So you need to be careful while drawing the heights. So let us take this first, distance between the center lines. So we will take this distance between the center lines in the front view. Okay, let us take this distance. Okay, we can keep this distance slightly closer instead of keeping it too far from the figure in this way, right? Then we need to give what is the height of this figure. So let us evenly distribute all the dimensions. So we will keep this height here 60, right? Let us give this height here 15. Now you can see that because of the snapping points, this 15 will be faced to this. So I will switch it off this for placing it, and then I will switch it on wherever it is required, right? So this is done. Now let us show what is the width of this. So you need to be shown in between in this way, right? Then we need to show what is the distance of this point, this top of this outline from this edge, which is 45. We'll show it here, okay, in this way, right? And then we need to show what is the distance between these two center lines, which is 35. Then we can show what are this circular hole size, which is here 516, right? Then we can show what is this distance of this from the edge. So for that we'll select this, it is 25, right? So we can see that most of the dimensions are marked. Let's check again whether we are marked 75, 60, 15. This 15 we already marked, this 25 marked, 10 marked, radius for this, radius for this outer hole, radius for this height is marked, right? So we have marked most of the dimensions, and now we can show the which one is this particular view. So we'll write down here sectional front view f dot v dot. Instead of the 8 mm as the height of the text, we can keep it as 5 to 6. Let us keep the 5. We can copy that here. Let us mark it as top view. We'll copy here. Let us mark it as RHSV, R dot S dot S dot V. So in this way we have completed the figure, and then finally you can uh, make the finishing work if it is required. Thank you.